Alright, guys. So today we're going to start solving systems of linear equations. And we're going to focus today specifically on graphing. Now, this lesson is really meant for you to just go through step by step. There are just a couple places where I think it's important for me to highlight some things with you. So I would encourage you to stop the video and just start working on it, and then periodically chime in to just check to see if your answers are correct. I've also provided an answer key as well, so you could just go back and just check the answer key. And then if you get stuck, come find the place where you're stuck and listen to my explanation. But for the most part, if you're reading through this whole lesson, it should be pretty self-explanatory. The main thing is the summary on the back of the first page and the summary on the top of the third page would be some places that you want to make sure you have that you understand the answers, and then I will really explain the word problem on the very back. So what I would suggest right now is just stop the video and do the whole front side and then check to see if your answers are right, either with this video or with the answer key I provided. So stop the video and just work on your own for a bit. Okay, so just to highlight a few things, solutions to linear equations, quick reminder, are your ordered pairs that fall on the line. So you could get these two ways. You could just plug your ordered pairs in here. So like here, if I put 3 into this equation for x and you add 2, you're going to get 5 for y. So you could just pick numbers for x and solve for y. Or you could come over to the line and find the x plus 2. This line has a y-intercept of 2 and a slope of 1. You could also just find solutions by picking ordered pairs on the line, right? So like 0, 2 is 1, 1, 3, 2, 4, 3, 5. So basically, I've just given you a sample of some solutions. So anything that falls along the line is considered a solution. Same with the other one, 1/3 x plus 4. Well, that would be this line. So my y-intercept here is 0, 4, and then all of these points, anything that falls on perfect corners, are exact solutions to this. So then the thing I want you to notice here is when you have these two lines, I was asking, do they have an ordered pair in common? And the answer is yes. Even if you didn't have it in your list, the answer is 3, 5. And that is actually the place where they intersect. So that ordered pair 3, 5 is what we call a solution to the system, because it's the ordered pair that the both lines have in common, and it's the place where they intersect. Which brings me to talking about some vocabulary, right? So here it's saying that a system of equations are 2 or more equations that have the same variables. The solution to a system is where the graphs intersect. And the ordered pairs where the graphs intersect are the ordered pairs that make the equations true. Now, there are 3 strategies to find a solution to a system. One is just by graphing them, which is what we're focusing on today. Then we're going to focus on a method called substitution. Then we're going to focus on a method called elimination. But today specifically, we're only going to focus on graphing. So if you haven't already answered questions 1 and 2, make sure you do that. Pay attention to my hints here in italics that kind of help you think through that. So stop the video, do it if you haven't already. So for these 2 questions, rather than actually graph them and see what the graphs look like, because they were multiple choice questions, I was just figuring out which one of these ordered pairs will make both of these equations true. And I found that the ordered pair 5, -2 works for both of them. So if I plug 5 in for x, I will get -2 for y. If I plug 5 in for x here and -2 in for y here, and I do the math, both sides end up being true. So C is the only ordered pair that works for both of them, which is what makes that a solution to the system. For question 2, all I did is I plugged -3, 5 into these right here, and I was looking for the ones that it works in both of them. It has to work in both for them to be a solution to the system, and I found that both B and D were my correct answers here. So now for the next one, I actually want you to graph these two lines on the graph and see what the solution is by hand. So quick reminder, in order for these to be easy to graph, the form that they should be in is slope-intercept form. So the question here, what form do the equations need to be in before you graph them? They either need to be in point-slope or slope-intercept. Since neither one of these are in point-slope form, the go-to is to put them into slope-intercept form. So stop the video and try to graph these and see where they intersect. So checking your lines, my red line is the top equation. My blue line I had to put into slope-intercept form, so I divided both sides by 2. My slope there is 3/2, and my y-intercept is 5. Now, the solution, you can't stop here. The solution is the place where the lines intersect. So my solution to this equation is the ordered pair -2, 2. Now, when I want you to check it, you're checking to see, does that ordered pair work in both equations? So I'm going to take the top equation, I'll write that one in red, and I'm going to say, since the top equation is y equals -2x minus 2, I'm going to put 2 in for y. I'm going to put -2 in for x, so I'm going to have -2 times -2 minus 2, and I'm just checking, is that a true statement? And so I'm going to get 2 equals, well, -2 times -2 is 4, and 4 minus 2 is 2. So that works. Now, to be a solution to the system, it has to work in both equations. So now let's take the equation 2y equals 3x plus 10. And I'm going to plug 2, -2, 2. So I'm going to put 2 in for y. So 2 times 2 is 4. And then I'm going to do 3 times -2 plus 10. I'm just going to make sure that's equal. So 3 times -2 is -6, and -6 plus 10 is 4. So it does work. So now, it does have to work in both of them. So if it doesn't work in both of them, you made a mistake somewhere. So you got to go back and check. All right, so these next two, you are going to have some strange things happening. So my advice to you is to just stop the video, try A and B, graph them, and then answer the questions at the bottom. So quick reminder, before you solve your system, what do you have to do to the equations first? You have to make sure that they're in slope-intercept form. So I'm going to write that again, make sure that they're in slope-intercept form, which again is y equals mx plus b. So make sure you put them in that form if they're not already there so that they're easy to graph. So stop the video, just graph A and B, and then answer the questions. All right, so this section, if you graphed your lines correctly, you might have some questions. So for letter A, what you should have noticed about the graphs above is that they are actually parallel. They're parallel lines, and so the solution to the system, they're parallel lines, so they don't have a solution because they never intersect. So you could say no solution with words, or you could put a circle with a line through it. So either way, when two lines are parallel, they have no solution. And then the two equations in the system, you just recently learned this, so if two lines are parallel, you know that the equations are going to have the same slope. So if you notice that two lines have the same slope but different y-intercepts, then they're going to be no solution. They're going to have no solution. Now the next one, what you notice about these two graphs is that once you put them both into slope-intercept form, they're the same equation, right? So if you have two equations that end up being the same, the solution to the system we say is infinite. Because the solution to the system are all of the ordered pairs that make the line true, right? And since this has an infinite number, since lines have an infinite number of solution, so would the system, okay? So we would say here that the solution here is infinite. So you could use the word, or you could write the symbol. The thing that you notice about the two equations is that they are the same, all right? Now, the last question on the bottom of this page says now look back at the first system you graphed and solved on this page. What do you notice about those two equations that make the system just have one solution, right? So what it is that makes something just have one solution is that they have different slopes. If you have two lines with different slopes, they will definitely intersect somewhere. So it's a little bit harder question. They have different slopes. So if you have two lines with two different slopes, they will have one solution. If you have two lines with the same slope, they will have no solution. And if you have two lines with the same slope and the same y-intercept, that is the same line, so their solutions are infinite. Now go ahead and go over to the next page and complete the summary for a system of linear equations. So a quick summary. If you have a system with just one solution, you're going to have two equations that have different slopes, and the graphs will intersect in one place. This is an example of one solution. If you have no solutions, that's because you have two parallel lines, meaning that equations have the same slope, and so when you write your equations, they should be the same slope. Now when you write your equations, don't write down the ones I have, come up with your own, right? So here you just have to have two equations that share the same slope. If you have an infinite number of solutions, it just turns out that they're the same exact line, meaning they have the same slope and the same y-intercept, so both of your equations should be identical. All right, now the cool thing about this is that we have this nifty tool called Desmos, and Desmos is a great way for you to check answers. Now, I just want you to know that you can do some of this stuff on Desmos. It's real easy. Basically, if you go to desmos.com and you choose Start Graphing, you can just type in the equations exactly the way that they are, and then it will create two lines, and if they have a solution, it will intersect somewhere, and you just click on their intersection point and it will give you the ordered pair. So I want you to try these completely on your own, and then I want you to just check the answer key that I provided to make sure that you did them correctly. I'm not even going to give these answers to you on this video because you can do this on your own. Basically, when it says how many solutions, just type that into Desmos. If they intersect, there's one solution. If they don't intersect, there's no solution. And if they end up intersecting on the same line, there's infinite solutions. Okay, so if you end up getting any crazy decimals, round to the tenths place. And then I want you to use the answer key that I provided to do that. When you're done with that, give the word problem a try, and then I'll do a good explanation of the word problem. Okay, make sure you have read this word problem and you've actually given it a try before you've started listening to my explanation, because my explanation will make a whole lot more sense if you've actually read the problem completely. So it says here that Edna leaves the trailhead and she hikes 12 miles toward the lake where her friend Maria is camping. At the same time, Maria starts her hike toward the trailhead, and then Edna is walking uphill, so she averages only 1.5 miles per hour, while Maria averages 2.5 miles per hour walking downhill. When and where will they meet? Now, because I'm asking you to write equation of system, you know you're going to have two separate equations, but we have to understand what does x represent and what does y represent. Well, our two unknowns for each person is how much time they're actually hiking. We have their rate, right? And then we don't know the distance that they're traveling. Like, we know where one starts, but we don't know the total distance that they've traveled once they meet up, right? So we know that Maria starts at the trailhead. So if she was to hike all the way to Edna, she would hike 12 miles. But Edna and her leave and they're walking towards each other. So they're not both going to hike 12 miles, right? They're going to together have hiked 12 miles, right? So Edna is hiking down to her, and so her distance down, eventually she's going to meet up with her friend, right? So x represents the time hiking, and y is going to represent their distance, and let's be specific. It's going to be their distance from the trailhead. because the problem is specifically asking you or telling you that we're discussing distance from the trailhead. Now we're going to write a system of two equations that model each girl's distance from the trailhead. So my hint here is that Edna starts at the trailhead, right? So when she starts, her distance from the trailhead is 0. And she is increasing her distance from the trailhead at 1.5 miles per hour. So her equation would be her distance, y, equals 1.5 x, because x stands for how long she's been traveling, right? She's going 1.5 miles every hour. So x is time, and we could up here specifically say x is time in hours, right? Because she starts at the trailhead, her y-intercept is 0. Now Maria, she starts 12 miles from the trailhead, and what's happening is her distance from the trailhead is decreasing as she goes down the mountain, right? Because she's getting closer to the trailhead. So her equation is going to be her distance is equal to 12 miles minus, she's decreasing 2.5 miles every hour. So it's minus 2.5x. You could say negative 2.5x plus 12 as well. So now when you go to graph this, Edna, instead of saying 1.5x, because 1.5 is my slope, I don't want to estimate 1.5. I want to know what's my actual rise over run. So since 1.5 is 1.5, change 1.5 to an improper fraction. That's 3 over 2. So off to the side here, I'm going to say Edna is y equals 3 over 2x. And Maria is going to be y equals 12 minus, well, 2.5 as an improper fraction is 5 over 2. So I'm going to make that minus 5 over 2x. So now if you look, when I go to graph it, I've made this graph nice and easy so that there are actually 12 slots as you go up. So you don't ever, if my scale is just 1, you're good. So let's say Edna, I'll do her in red. So Edna starts here at 0, 0. Sorry, want to use the pen. There we go. You do hers at 0, 0 here, and her slope is 3 over 2. So I'm going to up 3 over 2, up 3 over 2. And if you use the decimals as your slope, that's fine. Like you'll probably still get the same answer. And then let's do Maria's hike in blue. So she starts at 12. So she's 12 miles. That's, if you count, that is actually 12. And she's going down 2.5 every hour. So I made that 5 over 2. So I'm going to go down 5 over 2, down 5 over 2. And so if you look, they do intersect somewhere, right? Where they meet is going to be right here. And so let's just estimate what that is. This is an example of where like graphing might not be the best solution because it looks like we might have to estimate. But if you look at it, that looks like the ordered pair 3, 4.5. And that is actually the solution. So the solution is 3, 4.5. And if you don't believe me, you can go back to Desmos and type those equations in, and you should see that that's where they intersect. So the real world meaning of this solution, remember, x is representing the time. So after 3 hours, they are, well, the y is the distance from the trailhead. They are 4.5 miles from the trailhead. And that's what that means, okay? Now, if you're going to check Edna's equation by hand and Maria's equation by hand, what you're just basically going to do is take their equations and you're just going to plug the ordered pair 3, 4.5 into their equation. So Edna's equation was y equals 1.5x, so we're checking to see, does 4.5 equal 1.5 times 3? And it does. And then if I'm going to check Maria's, I'm just plugging Maria's equation in, 4.5 into Maria's equation. So I'm going to put 4.5 equals, Maria's equation was y equals 12 minus 2.5x. So I'm going to do 2.5 times 3, and I'm going to see, does that work, right? And so 2.5 times 3 gives me 7.5, so I get 4.5 equals 12 minus 7.5, and then 12 minus 7.5 does equal 4.5. And so you're just checking to make sure that that works. All right? Good luck with the practice.